Happy Labor Day, YouTube. How's everybody doing out there today? So today we're going to be going over how the AC coupled side of this system works. So essentially, in the last video, we went over how the DC system, it only charges batteries. So in this video, we're going to go through how the AC side of this system only provides power. And as you guys can see, I've got my Lynx distributor down here, and it has a couple of 4-aught wires that come over here to a Lynx distributor and a Lynx power in. And I'm actually using the Lynx power in as a Lynx power out, but that's neither here nor there. So essentially, for my battery packs over here, they come in down here to these fuses, and those fuses feed into the Lynx distributor, of which there is a fused link that goes in between each one of these circuits. That comes out of there into here, where it goes out to the two inverters. And if you notice on the bottom here, the inverters, they only have a power out connection. They are only AC out. These inverters shipped with 2 breakers that were right here. So I replaced that breaker with a 63 amp double pole breaker, because if one of the poles exceeds its limit, I want it to shut the whole thing down. I don't want to just leave 120 volts on, one half of a panel or something crazy like that. So I just put this double pole breaker in, and it is a listed breaker. So these are 12 kilowatt each. So each one of these SunGold power inverters here is 12 kilowatts. And the reason I had to do that is because the way that this house was set up, I didn't build this house, I bought it. It already came this way. It came with 2 200 amp panels in it, so that's 400 amp service. And trying to get that off the grid has been non-trivial. So essentially I ended up going with these Protran 2 50 amp panels, and you can see I've got 5 of these panels in total to take the circuits off the grid that I want off the grid. Another way I could have done this is I could have brought my power wires in and had those hooked up. So I could have brought those power wires in and had them hooked directly up to those main panels, but the problem that I would have encountered there is I wouldn't have been able to charge from grid. So anyways, now you know why I have 24 kilowatt hours or 24 kilowatts worth of inverter, because essentially one is going to power one panel and the other one is going to power the other panel. And I'll explain a little bit more of that funky setup in a minute. So anyways, so battery power comes into the bottom of the inverter. This inverter converts that to AC split phase. This is a low frequency transformer that's inside of there. It comes out 240, follows up and around these metal clad wires, which I really want to replace these with conduit. It's just what I could get done in a reasonable amount of time. Doesn't look the best. I mean, is it to code? Yeah, it's to code, but well, it's not the cleanest, honestly. At some point in time, I probably will poke through the back of the wall, come up through the ceiling, and then come back down in behind these. I just want to get the system up and running, test it, and even make sure it's going to work and be reliable and all those things before I go through that kind of effort. That's a lot of work to go through, and I will be able to reuse some of that metal clad wire to do that. So anyways, DC power comes in, AC power goes out via these inverters, comes all the way over and comes down into these panels here. So you can see where it comes in. Comes into this panel. It just comes into the bus bars in the back here. It does not go into a breaker. But then I have 3 50 amp breakers, and each of those 50 amp breakers goes to each one of these panels, right? And each one of these panels, so this setup here is a little bit weird, because when I bought this house, it used to have a generator. There was a generator panel in here. This place had an emergency generator wired into it, and it had a 16 circuit generator. And because some of the conduit was already pulled over to here and the wires were pulled here, I had to leave this panel here. I couldn't do anything with it. And these Protran 2 panels essentially allow me to tap into an electrical panel and turn this at my will into a sub panel. And when I say at my will, I mean at the circuit level. So I can take individual circuits on and off the grid. Also, what happens inside of one of these Protran 2 panels is the neutral gets tied. It comes up in through the bottom of this box and gets tied to the neutral bus. And it gets tied into the ground inside of your panel. So you don't have to worry about bonding. The bonding is handled by your main service panels. The bonding situation for your house with these types of panels does not need to change. And that has been a big concern with these off-grid inverters is how do I handle bonding? Well, these are UL listed for this application to be set up this way. I contracted Reliance Controls. I talked to them about my use case, and they said that this is an emergency service panel. Explained to me how it works, and essentially what happens is when this is in line mode, essentially what happens is the wire, so you see these red wires here? The red wire will come out, go into this box, it goes into the back side of the switch, and when this is in line mode, essentially it just bypasses it, and then it comes back out and goes back into the black wire and right back through your circuit. So this panel allows you to either use this breaker or bypass this breaker. And when it's in bypass mode, it turns this into a full sub panel. So this is a sub panel. It just has a switch on it that at the circuit level allows you to switch back and forth. So you could see on, I don't know if you can see in here or not. I'm gonna try to, the light situation is so bad. I guess you're not gonna be able to see that. You can't really see that my watt meter here is, it's at about 1,000 watts right now. And you see that load is equal on this panel. So this panel here and this panel here are tied into this main service panel. This panel here and this panel here are tied into this main service panel. And I've essentially just pulled all my big loads. The only thing I did not pull out of here was the hot water heater because I had a choice to make. I can only run one 30 amp circuit, and each one of my HVACs needs a 30 amp circuit. So in this panel, I already had a whole bunch of 30 amp circuits, and so I could only pull two over here, so I chose to pull the HVAC. And I left the water heater. That's why my water heaters in both panels are still connected to the grid as normal. So, I know that that's not ideal. I'd love to be completely off the grid, but I could not figure out a way to grid charge and then also be off grid, because the only other way I could do this would be to pull like a 60 amp breaker in here, put an interlock in, and then turn off the grid supply. But that doesn't really work because then I can't charge from the grid. And I do want to be able to charge from the grid. I mean, I don't want to act like the grid doesn't exist. This house was not designed to be off grid. So it is a pig. It is very power hungry. And this 24 kilowatt setup here will power all of the large loads, including the hot water heaters. If I wanted to put the tie hot water heaters into these, I surely could. I just don't have enough of those panels right now to do so. So anyways, if you guys have any questions, any more questions, I know this is not very complex. This is about as simple as an inverter setup can get. Connect from battery, go to the battery to AC into some form of sub panel, and that's it. Get you off the grid. If you got any questions, leave them in the comments. Everybody, hopefully you're having a great Labor Day.